Hey champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So in today's session we are going to discuss NEET 2015 chemistry paper that was cancelled, and we are total 45 questions here. So let's start the session. The first question is from the chapter hydrocarbons, and the question is the reaction of C6H5CH double bond CH3 with HBr produces. Okay, so we have an alkene given here, and we know that an alkene acts as a nucleophile. Okay, so let's draw the structure of this alkene. We have a benzyl group, so this is your benzene ring. It is attached to C, then this C has H, then double bond CH, and then CH3. Okay, this is the structure of the given alkene. Now this alkene has to react with HBr. Okay, now we know that bromine is more electronegative, so it will have a partial negative charge, and hydrogen will have a partial positive charge. Now since alkene is nucleophilic in nature, so it will have electrophilic attack of hydrogen on it. Okay, so this hydrogen will attack on the double bond. Now it can either attack carbon number 1 or it can attack on carbon number 2. Okay, it can get attached to carbon number 1 or carbon number 2. So it will lead to the formation of two different types of products. So let's see what are the different types of products. If it get attached to the carbon number 1, then the product will look something like this. It will be the carbocation. Okay, CH2, CH, and here a positive charge, and then CH3. Okay, these are the intermediates. And the other type of carbocation that can be formed is when this hydrogen will get attached to the carbon number 2. So it will look like this. This is the benzyl group. Here we have CH and a positive charge here, and the hydrogen has got attached to the second carbon, so CH2 and then CH3. Okay, these are different types of carbocations that can be formed. Now out of these two, which one will be more stable? The second one will be more stable, this one. Okay, because we know that benzyl carbocation is more stable due to the resonance effect. Okay, so this will be more stable, more stable. So the further reaction will take place on this carbocation. Okay, that means bromine will get attached to this carbocation. Now in the next step, bromide group will come and get attached at this position. So this is your CH, and bromine will also get attached to this. Okay, so Br, and then we have a benzyl group here, and then CH2, CH3. So if we write C6H5 in place of benzyl, it will be C6H5C, and then here bromine is attached, H is also there, then CH2, then CH3. This is the final product. So let's see which option has this. In the last option, option number D, you can see this is the same structure. So option D is the correct answer. Question number 2 is from the chapter Organic Chemistry, Some Basic Principles and Techniques. And the question is, in Dumas' method for estimation of nitrogen, 0.25 grams of an organic compound gave 40 ml of nitrogen collected at 300 Kelvin temperature and 725 millimeter pressure. If the aqueous tension at 300 Kelvin is 25 millimeter, then the percentage of nitrogen in the compound is. Okay. So the pressure, total pressure is given as 725 millimeter pressure, right? And out of that aqueous tension is 25 millimeter. So pressure of nitrogen gas will be 725 millimeter minus 25 millimeter. Okay, we'll subtract the aqueous tension from the total pressure. That will be the pressure of the nitrogen gas, that is 700 millimeter. So this is the pressure. Let's say this is P1. Okay, this is the value of P1. Now volume is given as 40 ml. This is V1, and the temperature is 300 Kelvin. This is T1. Okay. So P1 is equal to 700 millimeter, V1 is equal to 40 ml, and temperature T1 is equal to 300 Kelvin. Now what will be the value of P2 and T2? We know that at STP, pressure is equal to 760 millimeter. Okay. This is at STP. and temperature is 273 Kelvin. So these are P2 and T2. Now we have to find the volume at STP, that means V2. For that we'll use PV upon T constant. Okay, PV upon T is constant. That means P1 V1 upon T1 will be equal to P2 V2 upon T2. So from here we'll have to find the value of V2. Okay, this. So let's put the values. P1 is 700 millimeter, V1 is 40 ml, T1 is 300 Kelvin. This side P2 is 760 mm, then V2 we have to find out, and T2 is 273. So if you calculate this, you'll get the value V2 equals to 33.52 ml. So we have found the value of V2, that means volume at STP, volume of nitrogen at STP. Okay, now we know that the volume of 1 mole of nitrogen will be 22.4 liters. 22.4 liters, that means 22,400 ml. Okay, this is the volume of 1 mole of nitrogen. And what is the mass of 1 mole of nitrogen? 28 grams. Okay, 28 grams is the mass of 1 mole of nitrogen gas. So we know that mass of 22,400 ml nitrogen gas is 28 grams. So what will be the mass of 33.52 ml of nitrogen gas? We'll use the unitary methods. 28 divided by 22,400 into 33.52. That will be equal to 0.042. This is the mass that is collected in the above process. Okay, this is the mass of nitrogen collected. Mass of nitrogen collected. Here we are talking about nitrogen gas, right? That means N2, not nitrogen atom. So that mass is equal to 0.042, and we have to find out the percentage of nitrogen gas. So percentage of nitrogen gas will be equal to mass collected, mass of nitrogen collected divided by mass of the organic compound taken, organic compound, into 100, right? So mass of nitrogen collected is 0.042. What was the mass of the organic compound? It is 0.25 grams, right? 0.25 grams into 100. So if you solve this, you'll get 16.76%. This is the percentage of nitrogen, 16.76%. That means option B will be the correct answer. Question number 3 is from the chapter Equilibrium, and the question is the Ksp of silver chromate, silver chloride, silver bromide and silver iodide are respectively 1.1 into 10 to the power minus 12, 1.8 into 10 to the power minus 10, 5 into 10 to the power minus 13 and 8.3 into 10 to the power minus 17. Which one of the following salts will precipitate last if silver nitrate solution is added to the solution containing equal moles of sodium chloride, sodium bromide, sodium iodide and sodium chromate? Okay, so we know that when silver nitrate is added to sodium chloride, then what precipitate will be formed? Silver chloride will be formed as a precipitate, right? When it is added to sodium bromide, then the precipitate will be silver bromide. When it is added to sodium iodide, then the precipitate will be silver iodide. And when it is added to sodium chromate, Na2CrO4, then the precipitate will be silver chromate, that is Ag2CrO4. Now these precipitates that I have enclosed in this box, these are mentioned at the beginning of this question. Okay, the KSP values of these precipitates are given. So let's find the molar solubilities. Molar solubilities. That means S. Okay. The one which will have maximum value of molar solubility, when it will be maximum, then that solution will be the most soluble one. Okay. And then that will give the precipitate at last. Okay. It will precipitate last. So let's check which one has maximum value of molar solubility. So the first one that is mentioned in this question is silver chromate, Ag2CrO4. Okay. So we know that when it dissociates, it will give 2 Ag plus ion and CrO4 2 minus ion. Okay. This is 2s, this is s. So Ksp will be equal to 2s square into s, that is 4s cube. Okay. So from here we can say that the value of s will be equal to Ksp upon 4 power 1 by 3. So let's put the value of Ksp. Ksp of silver chromate is given as 1.1 into 10 to the power minus 12. So 1.1 into 10 to the power minus 12 divided by 4 is power 1 by 3. Now when you solve it, you will get the value 0.65 into 10 to the power minus 4. Okay. So it is the solubility, molar solubility of this one. Now we'll check the second one. Second one is silver chloride, AgCl. It will dissociate into silver ion and chloride ion, right? Ag plus and Cl minus. This is S, this is S. So its Ksp value will be equal to S square only simply. So S will be equal to under root of Ksp. Okay, this is simple. So we just have to find the square root of Ksp. What is the Ksp of silver chloride? It is given as 1.8 into 10 to the power minus 10. So 1.8 into 10 to the power minus 10. If you solve it, you will get the value 1.34 into 10 to the power minus 5. Okay. So we have got the second value of molar solubility. This was the first one. This is the second one. Now we'll find the third one. So third one is silver bromide. Again, it will dissociate into silver ion, Ag plus and Br minus ion. Okay, bromide ion. So here also Ksp will be equal to S square. So S will be equal to under root Ksp. So under root, what is the value of Ksp for AgBr? 5 into 10 to the power minus 10. Okay. 5. It was 5 into 10 to the power minus 10, right? Yes. Sorry, 5 into 10 to the power minus 13 it is. So 10 to the power minus 13. Now if you solve this, you will get the value 0.71 into 10 to the power minus 6. So this we have got the third value, and one more we have, this is silver iodide. Here also the value of S will be equal to under root Ksp, because it will dissociate into Ag plus and I minus ion. Okay, S and S, S square. So the value of S will be root of Ksp. So that is equal to under root. What is the value of Ksp for silver iodide? It is 8.3 into 10 to the power minus 17. So let's put that value. 8.3 into 10 to the power minus 17. Now if you solve this, you'll get 0.9 into 10 to the power minus 8. So this is the last value. So you can see all the four values here in the box. Which one is the maximum value? The first one is the maximum value, okay, because it has least negative power. It has least negative power of 10. So it is the maximum value. That means it will form the precipitate at last. Okay. So first one, that means Ag2CrO4, silver chromate. So option C, silver chromate, will be the correct answer. Question number 4 is from the chapter Chemistry in Everyday Life, and the question is Bethional is generally added to the soaps as an additive to function as a. Options are dryer, buffering agent, antiseptic and softener. So the correct answer will be antiseptic. Okay. Bethional, that is also known as bethionol, is added to soaps to impart antiseptic properties. Okay, let's see the structure of bethionol. Here we have two rings, one ring and the other ring. Okay, then we have OH, OH added to both the rings individually. Then these two rings are connected by sulfur, and then we have two chlorines attached to each of the rings. So this is the structure of bethionol. Bethionol. Okay. Option C is the correct answer. Question number 5 is related to isolation of elements, and the question is, metals are usually not found as nitrates in their ores. Out of the following two reasons, which is or are true for the above observation? First statement says metal nitrates are highly unstable. This statement itself is incorrect because metal nitrates are highly stable. Okay. Then the second statement says metal nitrates are highly soluble in water. Yes, this is a correct statement, and this is also correct reason for the above observation. Metals are not found as nitrates in their ores because these are highly soluble in water. What would happen if metal nitrates were present in the crust of the earth? These would be slowly and gradually washed by the rainwater into the sea. Okay, due to this reason they do not exist as nitrates. So A is false but B is true. Option B will be the correct answer. Question number 6 is from the chapter Chemical Bonding and Molecular Structure, and the question is the correct bond order in the following species is. Okay, so here we have three different types of bond species: O2 minus, O2 plus, and then O2 2 plus, right? So let's check the bond order one by one. First, we'll start with the negative. So O2 minus. Now we know that O2 has number of electrons 16. So minus sign means one more is added. So O2 minus will have 17 electrons. Okay. Now let's see the electronic configuration. It is sigma 1s2, sigma star 1s2, then sigma 2s2, then sigma star 2s2, then sigma 2pz2, then pi 2px2, pi 2py2, then pi star 2px2, and then pi star 2py2. Sorry, 2py1. Okay, 2py1 because we have 17 electrons. Now, bond order, as we know, is equal to half number of bonding molecular orbitals minus number of anti-bonding molecular orbitals. Okay. So in this case, number of bonding molecular orbitals is 10 and number of anti-bonding molecular orbital is 7. So half into 3, that means 1.5. So the bond order of O2 minus is 1.5. Now we'll check for O2 plus. So electronic configuration, first of all, what is the number of electrons? We know that O2 has 16 electrons. O2 plus means 1 has been removed from it. So 15 electrons. Now let's write the electronic configuration. Sigma 1s2, then sigma star 1s2, then sigma 2s2, then sigma star 2s2. Then we have sigma 2pz2, then pi 2px2, pi 2py2, then pi star 2px1. We have 15 electrons in total. Okay. Again, we'll find the bond order. It is half. What is the number of bonding molecular orbitals? Electrons in bonding molecular orbitals? 10. This will be same. Okay. Only anti-bonding will differ. Number of electrons in anti-bonding molecular orbital is 5 in this case. So half into 5 will be equal to 2.5. So this has the bond order 2.5. Now one more is left, that is O2 2 plus. O2 has 16 electrons. Now 2 removed from it, that means 14. So it will have 14 electrons in total. Let's write the electronic configuration. Sigma 1s2, sigma star 1s2, then sigma 2s2, then sigma star 2s2. Then first pi will come because for 14 electrons or less than 14 electrons, first pi comes. Okay, so pi 2px2, then pi 2p y2, then sigma 2p z2. So total 14 electrons. Okay, so let's write the bond order now. Half into number of electrons in bonding is 10, that will be same. Number of electrons in anti-bonding in this case is only 4. 2 and 2, 4. So half into 6 will be 3. Okay, in this case the bond order is 3. Now if you see, bond order is increasing from O2 minus to O2 plus and then O2 2 plus. Okay, 1.5 is least, 1.5, then 2.5 and then 3. That means the sequence of or the order of bond order will be O2 minus, then O2 plus and then O2 2 plus. Okay, so according to this, which one will be the correct answer? Option C will be the correct answer. Next question says the species argon, K plus and Ca2 plus contain same number of electrons. Okay, number of electrons are same. In which order do their radii increase? Okay, so we know here that argon is a noble gas and in this case it is neutral. Okay, it is a neutral species, whereas potassium and calcium are cations. Okay, we know that neutral species will have greater radius as compared to the cations when all have same number of electrons. Okay, and in cations also we have to remember that more the charge, lesser will be the radius, so the sequence will be like this: first neutral, then cation having lesser charge, cation with less charge, and then cation with more charge, because in cations electrons are removed, right? So more the electrons removed, lesser will be the radius. So here neutral one is argon, then cation with less charge is K plus and cation with more charge is calcium 2 plus. So this will be the correct sequence. Let's see which one is the correct answer. Argon maximum, then potassium plus, then calcium 2 plus. So option B will be the correct answer. Question number 8 is from the chapter Chemical Kinetics, and the question is the activation energy of a reaction can be determined from the slope of which of the following graphs. Okay, so we know that according to the Arrhenius equation, K is the rate constant, right? That is equal to A into e to the power minus EA upon RT. Okay, so if you put ln on both sides, ln K will be equal to ln A minus EA upon RT, right? So the activation energy of a reaction can be determined from the slope of ln K versus 1 by T. Okay, here T is inverse, T has the inverse relation, so 1 by T. So it will be ln K versus 1 by T. That means option B will be the correct answer. Question number 9 is from the chapter Chemical Bonding and Molecular Structure, and the question is which of the following pairs of ions are isoelectronic and isostructural? That means they have same number of electrons and they have same structure as well. Now if you look at the options, you can see in total we have 4 different types of species. One is ClO3 minus, then we have CO3 2 minus, then we have SO3 2 minus, and then NO3 minus, right? Only these four are present in different combinations. Okay. So let's see the number of electrons in each one of them. Number of electrons. In ClO3 minus, we have 17 for chlorine plus 3 oxygen, so 8 into 3, and then 1 minus charge means 1 more electron is added, so plus 1. So total number of electrons will be 42. Then we'll find the number of electrons in CO3 2 minus. So for carbon, 6, then 3 oxygens are there, so 8 into 3, and then 2 more electrons are added, so plus 2. So total number of electrons here will be 32. Then for SO3 2 minus, it will be 16 for sulfur, then 3 oxygens, so 8 into 3, and 2 more electrons added, so plus 2. So total number of electrons will be 42. And in the last one, NO3 minus, it will be 14 for nitrogen plus 8 into 3 because 3 oxygens and 1 more is added, so plus 1. So total number of electrons here will be 39. So you can clearly see which two are having same number of electrons, ClO3 minus and SO3 2 minus. Only these two make a combination with same number of electrons. So it is clear that option C will be the correct answer, but still we'll check whether they are isostructural as well. Okay. So we'll find the number of hybrid orbitals. Hybrid orbitals. For that, we have the formula half number of valence electrons on the central atom plus number of monovalent atoms, then minus charge on the cation plus charge on the anion. Okay, charge on anion. So this is the formula that we use. So we'll check for ClO3 minus first. ClO3 minus half number of electrons, valence electrons on central atom. So number of valence electrons on chlorine will be 7. Now there is no monovalent atom here, so 0 for that. Then there is no cationic charge, there is only anionic charge, okay, that is 1. So plus charge on anion, that is plus 1. So half into 7 plus 1, 8. That will be equal to 4. 4 hybrid orbitals means the hybridization is sp3. This is the hybridization. And the shape will be, or the structure will be pyramidal. Let's see the structure. This is Cl, a lone pair of electron here, double bond O, and then single bond O minus. Okay. Let's see for SO3 2 minus. SO3 2 minus. We'll use the same formula half. Number of valence electrons will be 6. Then here also no monovalent atom. Again no cationic charge, only anionic charge 2. Okay, so plus 2. So half into 8 again. So that is equal to 4. That is sp3 hybridization. Again it is proved that these two have same hybridization and same structure. This is also pyramidal in structure. This is sulfur, double bond O. Again the sulfur has lone pair of electron, O minus and O minus. Both have same structure and same number of electrons. So ClO3 minus and SO3 2 minus, option C will be the correct answer. Question number 10 is from the chapter Aldehydes, Ketones and Carboxylic Acids, and the question is an organic compound X having molecular formula C5H10O yields phenyl hydrazone and gives negative response to the iodoform test and tolerance test. It produces N-pentane on reduction. X could be. So first of all, let's draw the structure of all these compounds mentioned in the options. Okay. First is 2-pentanone. So CH3, C double bond O, CH2, CH2 and CH3. This is 2-pentanone. Okay. Then the second option is 3-pentanone. So it will be CH3, CH2, then C double bond O, then CH2, and then CH3. Third option is N-amyl alcohol. So it will be CH3, CH2, CH2, CH2. How many total number of carbons should be there in N-amyl alcohol? 5 carbons. Okay, so 1, 2, 3, 4, and then one more CH2OH. This is N-amyl alcohol. And then the last option is pentanal. So 5 carbons, CH3, CH2, 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 and then CHO. This is pentanal. Now, let's come to the question. It is given that this organic compound is giving negative response to iodoform test and tolerance test. Iodoform test is given by the methyl ketones CH3 C double bond O. So negative iodoform test means the compound should not be a methyl ketone. If you look at the first option, this is a methyl ketone, right? This part is CH3 C double bond O. So this is not the correct answer because the iodoform test is negative. Then it is also giving negative tolerance test. We know that tolerance test will be positive if it is an aldehyde. So this negative tolerance test means that it is not an aldehyde. So option D is also eliminated because it is giving negative tolerance test, negative response to tolerance test. So aldehyde is also eliminated. Now we have two options. What else is mentioned in the question? It is given that it will yield hydrazone, right? We know that hydrazone is yielded by carbonyl compounds. By carbonyl compounds. So out of B and C, second one, that means B is a carbonyl compound. C is an alcohol. It is not yielded by alcohol. So alcohol is also eliminated from here. So it is quite clear that option B will be the correct answer. And the last thing mentioned in the question is that it will produce N-pentane on reduction. So it is clear that when this second one will undergo reduction, then it will yield N-pentane. N-pentane, because this oxygen will be removed and H2 will be introduced. So it will give N-pentane. So option B, 3-pentanone will be the correct answer. Question number 11 is from the chapter Chemical Bonding and Molecular Structure. And the question is, which of the following options represents the correct bond order? So this question is very much similar to one of the previous questions we have done. Question number 6 it was, right? So similarly, you have to find the bond order using the same method that we used in question number 6. Okay, so here I'll explain in short. We have O2 minus, then O2, and then O2 plus. We know that O2 has how many electrons? 16 electrons. In O2 minus, one more electron will be added, so 17 electrons. And O2 plus, one has been removed from O2, so it will be 15 electrons. Okay, we know that the number of bonding electrons in bonding molecular orbital will be 10 in each case, right? So let's find the bond order. Bond order here will be half number of electrons in bonding molecular orbital, that is 10, and number of electrons in the anti-bonding molecular orbital will be 7. Okay, so it will be half into 3, that means 1.5. Now in O2, number of electrons in bonding molecular orbital will be same, that is 10, and that in anti-bonding will be 6. So it is half into 4, that means 2. And in O2 plus, half number of electrons in bonding molecular orbital 10, and that in anti-bonding will be 5. So half into 5, that means 2.5. So now you can see which one has maximum bond order. O2 plus. Okay, O2 plus, we can simply put the signs here. O2 plus maximum, then O2, and then the least is O2 minus. So according to that, which one should be the correct answer? Option A should be the correct answer, right? Option A is the correct answer. Question number 12 is from the chapter Organic Chemistry, and the question is, treatment of cyclopentanone with methyl lithium gives which of the following species? And the structure of cyclopentanone is shown here. So let's draw this structure like this. Okay, this is your cyclopentanone. Now it will be treated with methyl lithium. So this is methyl lithium. Okay, now we know that lithium acts as the electron donor. Okay, so it will donate the electron towards this methyl groups, due to which this carbon will have negative charge on it. Okay, then this methyl group will become negative. Now this carbonyl group, we know that if this is carbon and this is oxygen, so oxygen is more electronegative than carbon, due to which oxygen has partial negative charge and carbon has partial positive charge, right? So this negative methyl group will attack at this partial positive charge, okay? So it will form a structure like this. This is your single bond O minus, and then here CH3 group will be attached, and this is known as cyclopentanoyl anion. Cyclopentanoyl anion. So the correct answer will be option number D. Question number 13 is from the chapter Amines, and the question is the electrolytic reduction of nitrobenzene in strongly acidic medium produces. Options are azoxybenzene, azobenzene, aniline, and para-aminophenol. So for this, we should know that the reduction of nitrobenzene can be done in two different ways. Let's see. This is your benzene ring. This is nitro group. Okay. So this is nitrobenzene. Now, electrolytic reduction of nitrobenzene can be done in two ways. First, in weakly acidic medium, in weakly acidic medium, and then second, in strongly acidic medium. Okay, strongly acidic medium. In case of weakly acidic medium, it leads to the formation of aniline. Okay, aniline is produced, NH2, aniline. But here the question is asked about the strongly acidic medium. That means the second case. So in this case, first an intermediate will be formed. This is your benzene ring. Here you will have NH and OH. So this is phenyl hydroxyamine. Phenyl hydroxyamine. But this is the intermediate. In the next step, there is rearrangement. Okay, rearrangement takes place. Rearrangement takes place and OH groups comes at the para position. So this is the benzene ring. This is your NH2 because OH has been removed from here, and here OH. So this is the final product, and this is known as para-aminophenol. Para-aminophenol. So the correct answer will be option number D, para-aminophenol. Question number 14 is from the chapter D and F block elements, and the question is magnetic moment 2.84 Bohr magneton is given by. Okay, so we know that magnetic moment is given by the formula under root n into n plus 2, where n is the number of unpaired electrons. Number of unpaired electrons. Now here the value of magnetic moment is already given, 2.84 Bohr magneton. Okay, so according to that, under root n into n plus 2 is equal to 2.84, and we know that 2.84 is the square root of 8, right? So from here we can say that the value of n into n plus 2 is 8. Okay, so when is it possible? When the value of n is 2, then it will give 8. When we put n equals to 2, then n into n plus 2 will give 8. Okay, that means the correct ion should have how many unpaired electrons? 2 unpaired electrons. Now let's check which one of the given options has 2 unpaired electrons. For the first one, electronic configuration of titanium is argon, then 4s2. Let's write it down here, argon, 4s2, and then 3d2. This is for titanium, neutral one, okay? But here 3 electrons have been removed, 3 plus. That means 2 will be removed from 4s and 1 from this 3d. So what will be left? Argon, and then 3d1 will be left. That means 1 electron in the d orbitals. So here we have 5 d orbitals, 1, 2, 3, 4, 5. Okay, and only 1 electron in d orbitals. That means the number of unpaired electron here is 1 only. So this is not correct because it should be 2. Then second one, chromium 2 plus. What is the electronic configuration of neutral chromium? It is argon, then 4s1, 3d5. Now it is 2 plus, that means 2 electrons have been removed. So 1 will be removed from this 4s and 1 from this 3d. So what will be left? Argon and 3d4, right? So let's draw here. These are the 5 d orbitals. 4 electrons are there, 1, 2, 3, 4. So the number of unpaired electrons in this case is 4. So this is also not correct because we have to see which one has 2 unpaired electrons. Now third one is cobalt 2 plus. The neutral cobalt has the electronic configuration of argon, then 4s2, then 3d7. Now here we have 2 positive charge, that means 2 electrons have been removed. So these will be removed from the 4s, right? So 3d7 will be left. So it is argon and then 3d7. So here these are 5 orbitals, 5d orbitals, 1, 2, 3, 4, 5. 7 electrons are there. So 1, 2, 3, 4, 5 and then pairing will start 6, 7. So how many unpaired electrons? 3. Again this is incorrect. Now only one is left, that is nickel 2 plus. So we know that the electronic configuration of nickel is argon, then 4s2, then 3d8. Now this is 2 plus, that means 2 electrons have been removed from this 4s. So what is left? Argon and then 3d8. Now here we have 5 d orbitals, 1, 2, 3, 4, 5. 8 electrons have to be filled. So 1, 2, 3, 4, 5. Then pairing will start 6, 7, 8. So how many left unpaired? 2 electrons are unpaired. So number of unpaired electrons in this case is 2. This is what we were looking for. So this is the correct answer, option D. That means nickel 2 plus ion will have the magnetic moment 2.84 Bohr magneton. Question number 15 is from the chapter Solid States, and the question is, a given metal crystallizes out with a cubic structure having edge length of 361 picometer. If there are 4 metal atoms in one unit cell, what is the radius of one atom? Okay. So here it is given there are 4 metal atoms in one unit cell. That means we are talking about FCC lattice. And we know that in FCC lattice 4r is equal to root 2a, where r is the radius of the atom and a is the edge length. Edge length. We have to find out the radius of the atom r. So that will be equal to root 2a upon 4. Okay. So let's put the values root 2 into a, that means edge length is given 361 picometer divided by 4. If we divide 361 by 4, you will get 90.25. Okay. So it is 90.25 into root 2. Root 2 is equal to 1.414. On solving this, you'll get 127 and the unit will be picometer. So option A will be the correct answer. Question number 16 is from the chapter Haloalkanes and Haloarenes, and the question is, which of the following is the most correct electron displacement for a nucleophilic reaction to take place? So here if you look at the options, only the electron displacement steps are different, but the structure of the compound is same. Okay, what is the structure of the compound? It is CH3, CH3, then CH, then double bond CH, then single bond CH2, and then chlorine. Okay, this is the structure of the compound in all the given options. Now nucleophilic reaction has to take place. So for that we should remember one thing, that nucleophilic reaction takes place at low electron density position. Low electron density position. For that, first step will be the creation of low electron density position, okay, and that will be done by the removal of the halogen, because halogens are good leaving group. Halogen is good leaving group. So in all the given options you have a chloride present in the structure, right? So that chloride will leave, so it will create a positive charge to the carbon adjacent to the chlorine, okay? So this is the structure that we have drawn here, right? So first step will be removal of this chlorine from here. When this will be removed, this negative chlorine will be removed, then a positive charge will develop at the carbon adjacent to it, this one, okay? This positive charge will develop, so this will form the carbocation, okay? In the next step, this pi electron will shift towards the right side, okay, towards the positive carbon, okay, because pi bond is negative, right? So this pi electron will get shifted, it will push itself towards the positive charge. So this will be the correct way of electron displacement. Now let's see, in the first option, first chlorine is getting removed, this is correct, but after that this pi electron should be moved this side where the carbocation is formed, not towards the upper side where it is shown. So this is incorrect, okay? In the second one, chlorine is being removed from the right hand side, then here carbocation will develop, then this pi electron will be shifted towards this carbocation, so this is correct, okay? In the third one, chlorine is not getting removed, okay? There is no arrow near the chlorine, so it is showing that chlorine is not getting removed from here, so this is incorrect, because first chlorine should be removed to create the carbocation. In the last one, chlorine is getting removed from here, but there is no displacement of pi electron towards the carbocation, so this is also incorrect. The most correct way will be the second one, okay? Option B will be the correct answer. Question number 17 is from the chapter Solutions, and the question is, which one of the following electrolytes has the same value of Van 't Hoff factor I as that of Al2SO4 if all are 100% ionized, okay? So we have Al2SO4, it will dissociate into 2 Al3 plus ions and 3 SO4 2 minus ions, right? So what is the total number of ions here? 2 Al3 plus and 3 SO4 2 minus. So total number of ions is 5. So in this case, Van 't Hoff factor is equal to 5. Okay. Now we have to check which of the given options has Van 't Hoff factor 5. Okay. So the first one is K3FeCN6. Okay. Let's see what it will dissociate into. It will dissociate into 3K plus ion and FeCN6 3 minus ions. Okay. So how many total number of ions? 3 here and 1 here. So 4. So here Van 't Hoff factor is 4. That is not equal to the Al2SO4 3. Okay. So this will not correct answer. This will not be correct answer. Now we will come to the second one. It is AlNO3 3. It will get dissociated into Al3 plus ion and 3 NO3 minus ions. Total number of ions are 1 here and 3 here, 4. So again, Van 't Hoff factor is 4. So this will also not be the correct option because it's not equal to 5. Okay, it should be equal to 5. That means the same Van 't Hoff factor as Al2SO4 3. Now the third one, K4FeCN6. CN6. It will get dissociated into 4K plus ions and then 1 FeCN6 4 minus ion. CN6 4 minus ion. So the number of ions is 4 plus 1, that is 5. So here Van 't Hoff factor is 5. This should be the correct answer. Okay. This is same as that of Al2SO4 3. 5. But still let's check the last one also. This is K2SO4. So it will get dissociated into 2K plus ions and 1 SO4 2 minus ion. So in this case, total number of ions is 3. Van 't Hoff factor is 3. So this is also incorrect. The only correct answer is third one. Option C will be the correct answer. Question number 18 is from the P block elements, and the question is nitrogen dioxide and sulfur dioxide have some properties in common. Which property is shown by one of these compounds but not by the other? Okay. So first one is it is a reducing agent. So yes, both nitrogen dioxide and sulfur dioxide are reducing agent. So this property is common. Then the second one is soluble in water. So this is also common in both. Both are soluble in water. Third one is used as a food preservative. So only sulfur dioxide is used as food preservative. Nitrogen dioxide is not used as food preservative. Okay, not used as food preservative. Last one is forms acid rain. So both form acid rain. Okay, so three of the given properties are common to both, but one is shown by only one, that is sulfur dioxide. Okay, option C, food preservative. This is the function of sulfur dioxide only. Nitrogen dioxide is not involved in, it is not used as food preservative. Okay, so option C will be the correct answer. Now question number 19 says the total number of pi bond electrons in the following structure is. So this is very simple. How many pi bonds are there? 1, 2, 3, 4. So number of pi bonds is 4. And we know that 2 electrons form 1 bond, right? So number of pi electrons will be 4 into 2, that means 8. 8 pi electrons are there. Option A will be the correct answer. Question number 20 is from the chapter S block elements, and the question is solubility of the alkaline earth's metal sulfates in water decreases in the sequence. Okay, so what are the alkaline earth's metal? Beryllium, then magnesium, then calcium, strontium, and then barium. Okay, here we have metal sulfates. So barium sulfates, magnesium sulfate, calcium sulfate, strontium sulfate, and barium sulfate. Okay, now all these have almost same lattice energy, but their hydration energy is different. Okay, what happens? Hydration energy decreases on going down the group. Let's write it down here. On going down the group, the group, hydration energy decreases. Hydration energy decreases, and due to decrease in hydration energy, the solubilities will also decrease. Solubility will also decrease, okay, on moving down the group. So it will be maximum for beryllium sulfate, then magnesium sulfate, then calcium sulfate, then strontium sulfate, and then barium sulfate will have the least solubility. Here beryllium is not mentioned in the options, only magnesium, calcium, strontium and barium are mentioned. So the correct sequence will be the last one. Option D will be the correct answer. Question number 21 is from the chapter Chemical Bonding and Molecular Structure, and the question is maximum bond angle at nitrogen is present in which of the following? So let's see. First one is NO2 minus. Now we know that the number of valence electrons in nitrogen is 5 and one minus charge is there. That means one more electron has been added. So the total number of electrons will be 5 plus 1, that is 6. Okay, 6 electrons are there. Now let's see how these 6 electrons are involved here. This is nitrogen. So double bond oxygen, two electrons involved in these bond formation. Then one single bond oxygen with negative charge. Okay, because one negative charge is there. So one oxygen will have negative charge. So 3 electrons are involved in bond formation. One electron here has negative charge, 4, and 2 left. So these 2 electrons will be present as lone pair of electrons on the nitrogen atom. Okay. Now we know that we have 2 sigma bonds here plus one lone pair of electrons also. So number of sigma bonds plus number of lone pairs give the number of hybrid orbitals. So we have 3 hybrid orbitals. That means the hybridization here is sp2. Okay, sp2 hybridization is there. And sp2 hybridization has 120-degree angle, but due to the presence of lone pair, these angles will be decreased. Okay, both side angles will be decreased, so it will be slightly less than 120 degree. It will be around 115 degree. Okay, 115 degree. Now let's check for the second one. Here we have NO2 plus. So number of valence electrons on nitrogen 5, and 1 plus charge means 1 electron has been removed. So the number of electrons will be 5 minus 1, that is 4 electrons. Okay. Now let's see how these 4 electrons will be involved. This is nitrogen. We have 2 oxygens and no oxygen has negative charge, right? So double bond oxygen, double bond oxygen. 4 electrons involved here. All the 4 electrons are involved. Okay, no electron is left, so no lone pair is there. So here we have 2 sigma bonds plus 0 lone pair of electron. So the number of hybrid orbitals is 2. It means the hybridization will be sp hybridization. And sp hybridization means what angle? 180 degree. Okay. Now let's come to the third one. Here again we have 5 valence electrons on nitrogen and 1 negative charge, means number of electrons will be 5 plus 1, that is 6 electrons. Now let's see how 6 electrons will be involved here. In the first one also 6 electrons were there, but only 2 oxygens were present with nitrogen. Here 3 oxygens are there. So let's see. Double bond oxygen, and one more oxygen is there with the negative charge. So single bond oxygen with negative charge. So all the 6 electrons are involved here. Okay, 2 here in double bond formation, 2 in this double bond formation, 1 here and 1 negative charge. So 6 electrons are involved and no lone pair is present. So let's see, here number of sigma bonds is 3 sigma bonds and 0 lone pair of electron. 0 lone pair of electron. So number of hybrid orbitals 3. What will be the hybridization? sp2 hybridization. And sp2 hybridization means 120 degree angle. Since no lone pair is present, so there will be no decrease in the bond angle here. Okay, in the first one there was lone pair of electron, due to that the angle had decreased from 120 degree. But here no lone pair is present, so it will be exactly 120 degree. Now in the last one, NO2. So nitrogen 5 electrons. So here we have only 5 electrons. In the last one we have 5 electrons. There is no addition or removal of electrons in this case. Now let's see the structure. This is nitrogen, double bond oxygen, 4 electrons involved and one more electron is left. So that will be present on the nitrogen as lone electron. Okay, this is lone electron, not the lone pair of electron. Now we know that the lone pair of electron will decrease the angle, but here only single electron is there, and what happens? Single electron causes greater and uneven repulsion on both the oxygen atoms, and it leads to splitting them from each other. Okay, and it causes the increase in bond angle. Okay, lone electron causes increase in the bond angle, instead of decreasing the bond angle. This you have to remember. There is a concept behind that you'll study in the chapter. Okay, so here the bond angle will be increased from 120 degree. Okay, here the hybridization is what? Hybridization is 3, because 3 sigma bonds are there. Sorry, 2 sigma bonds are there plus 1 electron is there, so that will also be taken as 1 hybridization, 1 orbital. Okay, so 2 plus 1, that means 3, and it will be sp2 hybridization, but the angle will be more than 120 degree in this case due to the presence of single electron. Okay, so it will be exactly, if we say, it will be 134 degree. Okay, so if we compare the bond angles, which one is the maximum? Second one, 180 degree is the maximum, so option B will be the correct answer. Question number 22 is from the chapter Equilibrium, and the question is, if the value of an equilibrium constant for a particular reaction is 1.6 into 10 to the power 12, then at equilibrium the system will contain option A mostly reactants, option B mostly products, option C similar amounts of reactants and products, and option D all the reactants. Okay, so we know that the value of equilibrium constant indicates the extent to which a reaction proceeds. Okay, extent to which the reaction proceeds. Now if you look at the value of the equilibrium constant given here, you can see that this is a very large value. This is a very large value of equilibrium constant. And the large value of equilibrium constant means that the amount of or the concentration of product will be large. Concentration of product will be large. Okay, because the reaction proceeds to the right hand side, resulting in the increased concentration of the products. So mostly products will be present. Option B will be the correct answer. Question number 23 is from the chapter D and F block elements, and the question is the number of d electrons in Fe2 plus whose atomic number is 26 is not equal to the number of electrons in which of the following. So first let's find the number of d electrons in Fe2 plus with which we have to compare. If we write the electronic configuration of Fe2 plus, at last you will get 3s2, 3p6 and 3d6. So in this the number of d electrons are 6. Okay, 6 d electrons are present in Fe2 plus. So we have to compare in each of the given options. Okay, the first option is p electrons in chlorine. So let's see how many p electrons are present in chlorine. The electronic configuration is 1s2, 2s2, 2p6, 3s2 and then 3p5. Okay, total 17 electrons because atomic number is 17. Now how many p electrons are there? 6 p electrons here and 5 p electrons here. So total 11 p electrons. This is not same as the number of d electrons in Fe2 plus because that was 6. Okay, so this is incorrect. Let's check the second one. Number of d electrons in Fe. Okay, let's see what is the electronic configuration of iron. Electronic configuration of argon, then 4s2, 3d6. So here the number of d electrons is 6. 6 d electrons are present. So yes, this is same. The third option is p electrons in neon. Electronic configuration of neon is 1s2, 2s2, 2p6. Okay, 10 electrons. So here how many p electrons are there? 6 p electrons. 6 p electrons. So this is also same as the number of d electrons in Fe2 plus. Then the last one is s electrons in magnesium. So the electronic configuration of magnesium is 1s2, 2s2, 2p6 and 3s2. So how many s electrons are there? 2 s electrons here and 2 s electrons here. So and 2 here also. Okay. So 2 plus 2 plus 2, that means 6 s electrons. Again the number is same as the number of d electrons in Fe2 plus. So in the options B, C and D, the number is same, but the first one is not same. So option A will be the correct answer. Question number 24 is from the chapter Organic Chemistry, and the question is in which of the following compounds the carbon chlorine bond ionization shall give most stable carbonium ion. Okay, so we know that the tertiary carbocation is the most stable, then secondary carbocation and then the primary carbocation. Okay, if we check the first one here, the carbocation that will be formed will be the tertiary carbocation. Okay, this is your carbon, this is CH3, then CH3 here and CH3 here. Positive charge on carbon. So this is tert butyl carbonium ion. Tert butyl carbonium ion. And this will be very stable. Very stable. Then in the second one, we'll get a benzyl carbonium ion. Okay. This is your benzene ring. This is carbon CH and then one more H, positive charge here. This is benzyl carbonium ion, and this will also be very stable due to resonance. Due to resonance. In the third one, we have NO2 group. Okay, we know that nitro group is electron withdrawing in nature. This is electron withdrawing nature. So instead of stabilizing the carbonium ion, it will destabilize the carbonium ion. Okay, so there will be destabilization. destabilization. So this is not at all stable. Then in the last one, we'll get a secondary carbonium ion. Okay, here we'll get a secondary carbonium ion. So secondary carbonium ions are less stable than the tertiary carbonium ion. Okay, this is also less stable. But the first two options, both should be correct. Actually, both can be correct because both are very stable. Okay, but the tertiary carbonium ion, the first one will be slightly more than the second one. But still, in some places you'll find that the second one is most stable due to resonance. So there is confusion in this question. Please check the official answer key, which answer is marked as the correct one. Question number 25 is a device that converts energy of combustion of fuels like hydrogen and methane directly into electrical energy is known as. Options are electrolytic cell, dynamo, nickel cadmium cell and fuel cell. So the correct answer will be option number D, fuel cell. Okay. Now question number 26 is from the chapter organic chemistry and the question is consider the following compounds hyperconjugation occurs in. So, what is hyperconjugation? It is delocalization. Let's write it down here. Delocalization of conjugate carbon hydrogen sigma bond electron with sp2 hybridized carbon. Okay. Now this sp2 hybridized carbon can have a double bond. It can have a positive charge. That means it can be a carbocation or it can be a free radical. Okay. If there is an alpha hydrogen present there, then delocalization of the conjugate carbon hydrogen sigma bond electron will take place. So let's check. In here we have three different compounds. In the first one, this is the free radical. Okay, this carbon that I have enclosed in the box is the free radical carbon. Can you find any alpha hydrogen there? On the right hand side, this is the position. Okay, this is the first position. On the left side, this is the second alpha position. Okay, at both the positions, there are no alpha hydrogens. Okay, so in the first one, no alpha hydrogen is present. So no hyperconjugation will take place. Now in the second compound, you can see phenyl groups are there. Now phenyl group is forming a bond with this carbon. This is the free radical carbon. So at alpha positions, there will be no hydrogen here also. Okay, no alpha hydrogen in this case also. Okay, so it will also not show hyperconjugation. In the third one, this is the free radical position. Okay, this position is the free radical position. Now on the right side of this radical, we have this position. This is number one. This is number one alpha position. So at this position, you will have alpha hydrogen. Alpha hydrogen will be present at this position. On the left side, we have bridge-headed carbon. This is the bridge-headed carbon. And we know that the alpha hydrogen, even if they are present on the bridge-headed carbon, they will not take part in the hyperconjugation. But at least at this position, the alpha hydrogen will take part in the hyperconjugation. So this compound will show hyperconjugation. Okay. So only in the third one. So option B, 3 only will be the correct answer. Question number 27 is from the chapter alcohols, phenols and ethers. And the question is the reaction is called. Okay. A reaction is given here. We have to find what is the name of this reaction. Options are Williamson continuous etherification process. Option B, Etard reaction. Option C, Gattermann-Koch reaction. And option D, Williamson synthesis. So if you look at this reaction, the first reactant here is an alkoxide, right? It is a sodium alkoxide. Sodium alkoxide. Then it is reacting with an alkyl halide. Okay, it is reacting with alkyl halide. As a result, what is formed? Ether is formed. So we know that this process is known as Williamson synthesis. Okay, this reaction is important for the preparation of symmetric and asymmetric ethers. It is used for the preparation of symmetric and asymmetric ethers, and the name of the reaction is Williamson synthesis. Option number D will be the correct answer. Question number 28 is from the chapter Coordination Compound, and the question is cobalt 3 chloride forms several octahedral complexes with ammonia. Which of the following will not give test of chloride ions with silver nitrate at 25 degrees Celsius? So let's see what will be the complexes formed in each case. We know that the normal coordination number of cobalt is 6. That means within the coordination sphere, 6 molecules can be present with cobalt. Okay, so this is cobalt. 4 ammonia are there and 3 chlorines are there. But maximum 6 can be present inside the coordination sphere. So 4 ammonia will be there. And then 2 chlorines can be there. Okay, because maximum 6 can be there. So 1 chlorine is left that will move outside the coordination sphere. Then in the second one, 5 ammonia and 3 chlorine. So this is cobalt, 5 ammonia, NH3 5, and one more. So 1 chlorine can be present and 2 chlorines will move outside the coordination sphere. Okay. Then in the third one, we have 6 ammonia. So all the 6 molecules here will be ammonia. And then all the 3 chlorines will be outside the coordination sphere. Ammonia will not be present outside the coordination sphere. In the last one, we have cobalt, then 3 ammonia, NH3, 3, and 3 chlorines. So 6. No chlorine is present outside the coordination sphere. So in the first 3, chlorine is present outside the coordination sphere. In the last one, no chlorine outside the coordination sphere. So if it reacts with silver nitrate, it will not give precipitate. Okay, it will not form precipitate. So it will not give the test of chloride ions. Not give the test of chloride ions. Option D will be the correct answer. Question number 29 is from some basic concepts of chemistry, and the question is a mixture of gases contains H2 and O2 gases in the ratio 1:4. What is the molar ratio of the two gases in the mixture? Okay, so the ratio of masses are given. That means if H2, the mass of H2 is 1 grams, then the mass of O2 is 4 grams, right? We have to find the ratio of moles, right? Molar ratio means the ratio of number of moles. So the number of moles of H2 will be given mass, that means 1 grams, divided by the molar mass of hydrogen, that means 2 into 1, 2. So this is the number of moles of hydrogen gas. For O2, number of moles will be equal to given mass, that means 4, divided by the molar mass of O2, that means 2 into 16. So it will be 32. Okay. 4 divided by 32. That means 1 by 8. Now we have to find the molar ratio. So number of moles of H2 upon number of moles of O2. 1 by 2 divided by 1 by 8. So 8 will go up. It will be 4 by 1. That means the ratio is 4:1. It is very simple. Option A will be the correct answer. Question number 30 is from D and F block elements, and the question is which of the following processes does not involve oxidation of iron? So let's see, the first one is decolorization of blue copper sulfate solution by iron. So what happens when iron reacts with copper sulfate CuSO4, then it gives FeSO4 and copper. Initially on the reactant side, the oxidation state of iron was 0. Okay, it was in its elemental form. On the product side, the oxidation state of iron becomes +2. So we can see there is increase in oxidation state. So increase in oxidation state means oxidation is done. Okay, so here oxidation takes place. In the second one, formation of FeCO5 from Fe. So Fe, that means iron, reacts with 5CO to give FeCO5. Here on the product side also the oxidation state of iron is 0. Okay, that means there is no change in oxidation state. No change in oxidation state of iron. That means no oxidation takes place here. So this should be the correct answer. Let's check others. In the third one, liberation of hydrogen from steam by iron at high temperature. We know that addition of oxygen or removal of hydrogen is known as oxidation. It takes place during oxidation. So since hydrogen is being liberated or removed from steam, that means oxidation is taking place. So here also oxidation takes place. In the last one, rusting of iron sheets, we know that the process of rusting also involves oxidation. What happens? Suppose this is iron. After rusting, it becomes Fe2O3 dot XH2. Okay, so initially the oxidation state of iron was 0, but after the reaction the oxidation state of iron becomes +3. So here also increase in oxidation state takes place. So oxidation is done here. Only in the second one, okay, oxidation is not taking place. So option B will be the correct answer. Now this is again from D and F block elements, and the question is, because of lanthanoid contraction, which of the following pairs of elements have nearly same atomic radii? Okay, so we know that zirconium and hafnium have almost same atomic radii due to the lanthanoid contraction. So option B will be the correct answer. Question number 32 is from the chapter Equilibrium, and the question is, which of the following statements is correct for a reversible process in a state of equilibrium? Okay, so we know that at equilibrium delta G is equal to 0. Delta G is equal to 0. Therefore, delta G naught is equal to minus 2.303 RT log K. Okay, so the correct answer will be option number B. Okay. Question number 33 is from the chapter Structure of Atom, and the question is, the angular momentum of electron in d orbital is equal to. So we know that the formula for orbital angular momentum is under root L into L plus 1 h by 2 pi, and h by 2 pi can be written as h bar because in the options h bar is given. Okay, so we'll use h bar. So under root L into L plus 1 h bar. Now here we have d orbitals. For d orbital, the value of L is 2. So we'll put the value of L 2. 2 into 2 plus 1 into h bar. That means under root 2 into 3 6. Okay, root 6 h bar. So according to this, what should be the correct answer? Option D, root 6 h bar will be the correct answer. Question number 34 is from the chapter Solutions, and the question is, the boiling point of 0.2 mole per kg solution of X in water is greater than the equimolar solution of Y in water. Which one of the following statements is true in this case? First option is molecular mass of X is greater than the molecular mass of Y. Then option B, molecular mass of X is less than the molecular mass of Y. Option C, Y is undergoing dissociation in water while X undergoes no change. And the last one is X is undergoing dissociation in water. Okay, so it is given that we have equimolar solutions of X and Y, right? That means the molality is same. Molality M, small m, is same. Then the solvent is also same for both. Okay, in both the cases the solvent is water. So for same solvent the value of the constant Kb is same, and we know that the formula for elevation in boiling point delta Tb is equal to I into Kb into molality M. Okay, Here Kb and m are same, that means delta Tb will depend on the Van't Hoff factor I, right? So here it is given that the boiling point of x is greater than y. That means delta Tb for x is greater than delta Tb for y. That means I for x will be greater than I for y. And when the value of I is greater, it means x will be undergoing dissociation. Okay, x will be undergoing dissociation. So the correct answer will be option number D. Y is, see, option C cannot be correct because if Y would undergo dissociation, then its I would be greater. Okay, but it is not so. Then molecular masses will have no effect since overall molality is same. So option number D will be the correct answer. Question number 35 is from S block elements, and the question is, the function of sodium pump is a biological process operating in each and every cell of all animals. Which of the following biologically important ions is also a constituent of this pump? So this is very simple. We know that both sodium and potassium are involved in the sodium pump. Okay, so here sodium is not mentioned but potassium is mentioned, so option B will be the correct answer. Question number 36 is from the chapter Hydrocarbons, and the question is, the enthalpy of the hydrogenation of these compounds will be in the order as. Okay, so the structure of three types of compounds are given and we have to find the correct order of enthalpy of hydrogenation. What is hydrogenation? It is a process in which hydrogen is added to the unsaturated compounds and then it becomes saturated compounds, okay, after the addition of hydrogen, because double bonds are removed. So we know that the enthalpy of hydrogenation will be inversely proportional to the stability of the alkene. Okay, stability of the alkene. So the less stable or the least stable alkene will have highest enthalpy of hydrogenation and the most stable alkene will have lowest enthalpy of hydrogenation. Okay, so here if you look at the structures, in the first one we have a benzene ring, so there is resonance in this case. Okay, and due to resonance this will be very stable. Okay, due to resonance it is very stable. In fact, out of the three structures, this one will be the most stable. So the first one will have the least enthalpy of hydrogenation. Okay, then the second one, there is the benzene ring is not complete, but due to conjugation it will also be stable. Okay, here we have conjugation, so it will also be stable but it will be less stable than the first one, less stable than the first one. So it will have the enthalpy of hydrogenation of the second one will be more than the first one. And then in the last one we have no resonance and no conjugation. This is the least stable alkene. Least stable alkene because this is isolated alkene. Okay, so it will have maximum enthalpy of hydrogenation because it is least stable. So the correct order will be 3, then 2, and then the last one is 1. So option number A should be the correct answer. Okay, now question number 37 says the enolic form of ethyl acetoacetate as shown below has. So we simply have to find the count the number of sigma bonds and pi bonds. Okay, so what is the total sigma bonds here? If you count, it will be 18 sigma bonds and only 2 pi bonds. Okay, so the correct answer will be option number D, 18 sigma bonds and 2 pi bonds. Question number 38 is from the chapter Polymers, and the question is, biodegradable polymer which can be produced from glycine and aminocaproic acid is. Options are PHBV, Buna N, nylon 66 and then nylon 2 nylon 6. So the correct answer will be option D, that is nylon 2 nylon 6. Let's see the reaction. We have glycine, NH2, CH2, COOH. This is your glycine. it reacts with N molecules of NH2, CH2 COOH. This is aminocaproic acid. Aminocaproic acid. Then as a result, the polymer that is formed is NH, CH2, C double bond O, NH, then CH2 then C double bond O again. This is your polymer that is known as nylon 2, nylon 6. So the correct answer is option number D. Next question says that which of the following species contains equal number of sigma and pi bonds? Again, we simply have to count the number of sigma and pi bonds. So let's check. In the first one we have xenon O4. So this is your xenon double bond O. There are 4 oxygens all with double bond, right? So you can see that the number of sigma bonds is 4 and the number of pi bonds is also 4. So here the number of sigma and pi bonds are equal. So it should be the correct answer. Let's check others. Second one is CN2. So 2 carbons and 2 nitrogen. So carbon-carbon single bond. Then each carbon has triple bond with nitrogen. So here number of sigma bonds is 3 and the number of pi bonds is 4. Okay, 2 here and 2 here, 4. So it is not equal. So this is not correct answer. Third one, CH2, CN2. So let's see the structure. CH2. So 1H, 2H. Then 2CN. C triple bond N and one more C triple bond N. Okay. So what is the number of sigma bonds? 1, 2, 3, 4, 5, 6. It is 6 and number of pi bonds 2 this side and 2 this side. So pi bonds is 4. Again both are not equal. So incorrect. And the last one is HCO3 minus. So C double bond O, here OH and O minus. Okay, this is the structure. What is the number of sigma bonds? 1, 2, 3 and 1 between O and H, so 4. And number of pi bonds is only 1. So again not equal, incorrect. The only correct answer is the first one. Option A is the correct answer. Question number 40 is from the chapter coordination compound and the question is which of these statements about cobalt CN6 3- is true? Okay. So first of all let's check what is the oxidation number of cobalt here. Let's say the oxidation number of cobalt is X plus we know that the oxidation state of Cn is -1. So here we have 6 Cn, that means -6. The sum will be equal to -3 because the overall charge is -3. So X minus 6 is -3. So X will be equal to -3 plus 6, that means +3. So oxidation state of cobalt is +3, that means the electronic configuration will be 3d6. Okay, 3d6, that means 6 electrons in the d orbitals. Now we see the hybridization. We have 3 T2G level here and 2 EG level. Okay, and this is a strong field ligand, right? Cobalt is a strong field ligand. So let's start filling the electrons. 6 electrons are there, so 1, 2, 3. Now since it is a strong field ligand, so pairing will take place in the lower orbitals only. Okay, 4, 5, 6. So all the 6 electrons completed in the lower T2G orbitals. Now let's see the options. In the first one, it is given that it has 4 unpaired electrons and will be in a low spin configuration. So we can see that there is no unpaired electron. Okay, all the 6 electrons are paired in the lower T2G orbitals. So this is incorrect. Then the second option is again it has 4 unpaired electrons, which is incorrect because there are no unpaired electrons. In the third one, it is given that it has no unpaired electrons and will be in the high spin configuration. So the first part is correct. It has no unpaired electrons, but it is not in a high spin configuration. it is in the low spin configuration, because you can see that the pairing of the electrons has taken place in the lower energy level only. Okay, so it is low spin configuration. This is incorrect. The last one is it has no unpaired electrons and will be in a low spin configuration. Yes, this is correct statement. So option D is the correct answer. Question number 41 is from the chapter Thermodynamics, and the question is which one is not equal to 0 for an ideal solution? So this is again very simple. We know that entropy of mixing cannot be 0 for an ideal solution. Okay, it is always more than 0. That means it is positive, because a solvent in a solute has more molecular disorder. Solvent has more molecular disorder. So a large value of entropy of mixing. Entropy of mixing is positive, not 0. Option A will be the correct answer. It is not equal to 0 for an ideal solution. Question number 42 is from the chapter Surface Chemistry, and the question is which property of a colloidal solution is independent of charge on the colloidal particles? Options are electrophoresis, electroosmosis, Tyndall effect and coagulation. So we know that electrophoresis, electroosmosis and coagulation, all of these depend on the charge on the colloidal particle, whereas Tyndall effect being an optical property, it is an optical property, does not depend on the charge of the colloidal particle. Okay, it is independent of the charge on the colloidal particle. So option C will be the correct answer. Question number 43 is from the chapter Organic Chemistry, and the question is which of the given compounds can exhibit tautomerism? So we know that for tautomerism to take place, alpha hydrogen must be there. Okay, alpha hydrogen. So if this is your carbonyl group, then at the alpha position, if this is your alpha position, a hydrogen must be present. Okay. And what happens? This carbon oxygen double bond gets converted into carbon single bond OH. Right. Now let's check in the first one. This is your carbonyl group. On the right hand side, if you see at alpha position, we have hydrogens. Okay. So this will undergo tautomerism. And let's see the compound, what will be formed. This is your ring. Here we have a pi bond, and then this bond will move here and here will get OH, right? And then two methyl groups here. This is the product. Then in the second one, again on the right hand side of the carbonyl group, we have hydrogen at alpha position. Okay, here we'll have hydrogen, so this will also undergo tautomerism. And let's see the product. This is the ring. This bond will move here. This is the carbon OH bond and two methyl groups at this position. Okay. Now let's come to the third one. Now visibly, if you see, there are no alpha hydrogen present on either side of the carbonyl group. Okay. On the left hand side, we have this and this sp2 hybridized carbon, and on the right hand side, we have two methyl groups. So there is no alpha hydrogen here attached to the sp2 sp3 hybridized carbon. Okay. Alpha hydrogen should be attached to the sp3 hybridized carbon. So here what happens, some delocalization will take place. We know that in case of tautomerism, it can take place in acidic as well as basic medium. So if the reaction is carried out in basic medium, then the third one also can undergo tautomerism. Let's see how. This is your compound. This is the ring, double bond O, two methyl groups here, right? Now here we don't have alpha hydrogen attached to the sp3 hybridized carbon on either side, but we have a alpha hydrogen here at this position. That means gamma hydrogen, not alpha hydrogen, but gamma hydrogen is there. So in basic medium, what will happen? This hydrogen will be removed. H plus will be removed. So minus charge will be created at this position. Now delocalization will take place. This minus charge will come here and this bond will come here. So what will be formed? This is your ring. Here we'll have this bond and the minus sign here, double bond O and two methyl groups at this position. Then in the next step, this alpha hydrogen will come at this position where negative charge is present. It will get attached at that position. So we'll get alpha hydrogen at this position. Okay, hydrogen will get attached here, and double bond is present here, two methyl groups here, and double bond O is here. Okay, so now we have got the alpha hydrogen at this position. So at this step, it can undergo tautomerism. So here gamma hydrogen is not taking part in the tautomerism directly, but after getting relocalized, we are getting alpha hydrogen. Okay, and then this alpha hydrogen is taking part in the tautomerism. So the final product will look like this. This is your ring, double bond here, double bond here, OH. Okay, here OH will get, and then two methyl groups here. So all three are undergoing tautomerism. That means option number C, 1, 2 and 3 is the correct answer. Question number 44 is from the chapter Chemical Kinetics, and the question is, when initial concentration of a reactant is doubled in a reaction, its half-life period is not affected. The order of the reaction is, options are first, second, more than 0 but less than first, and the last one is 0. So again, very simple, we know that in case of first order reaction, T half is equal to 0.693 upon K. Okay, that means the half life does not depend on the initial concentration. It is half life is independent of the initial concentration of the reactant. Therefore, even if the initial concentration will be doubled in the reaction, its half life period will not be affected. Option A will be the correct answer. Now we have come to the last question, and the question says a single compound of the structure this is obtainable from ozonolysis of which of the following cyclic compounds. Okay, so if we see, there are 1, 2, 3, 4, 5. 5 carbons in a chain. Now if we try to form the cyclic compound from this, these 5 carbons will get attached to each other, so they will form a 5 carbon ring. Okay, so it will be a pentagon, 5 carbon ring. Okay, now here we have the double bond between first and fifth carbon. Okay, here we have a double bond, so double bond will be present between first and fifth carbon. Okay, it's first, second, third, fourth, fifth, double bond. And then you can see that at third and fifth position we have methyl groups attached. Okay, so one methyl group here and one methyl group here. So here you can see methyl groups are present after one position. Okay, between them there is one position that is not occupied by any group. So in the first option you can see that the methyl groups are present on adjacent carbons, but it is not correct. Okay, because they should be present after leaving one position. So this is incorrect. In the second one, both the methyl groups are shown at one position only. This is also incorrect. Then in the third one, again, these two methyl groups are present on adjacent carbons. So this is also incorrect. And in the last one, yes, in the last one, these are present after leaving one position in between. So this is the correct one. Okay. Now let's see if it undergoes ozonolysis, then it will give the product that will look something like this. Here we have CH3. Here we have carbon oxygen double bond, CH3 here, and then here CHO. Okay, this is the final product. So option D will be the correct answer. So here we complete all the questions from NEET 2015 chemistry paper that was cancelled. Okay, we will be back with another session very soon. Till then, keep learning, keep scoring high. For a better understanding, I would suggest you to practice same questions from our website www.examsnet.com. And for more information, please download our app from the link given in the description box. Thank you so much.